Today I'm going to review this Micsig oscilloscope. This is a brand new, recently released one. It's only just come out. I was talking to Micsig and they were willing to send me this one. I think there's nobody else who's got videos on these things out there really. So this scope is a 300 megahertz scope. 300. It's the top of the range one. So you offer 300, 200 and 100 megahertz options. And so this is the top of the range one, which has got slightly better sample rate and stuff like that. This is pretty cool. Now you may see you've got some bubbles on the screen here. The guy who sent this to me from Micsig said to me in an email that he messed it up and he got some bubbles and stuff in it and bits of dirt, little grains of dust or something in there. So he has actually sent me a second one to replace it with. So it doesn't bother me enough at the moment to worry about changing it, but if it does bother me I will sort it out later on. So don't worry about these. This won't necessarily come on yours. They do supply it with a screen film to put on to reduce the reflections. It's up to you to put it on normally, but they did this for me to make it a bit easier for me. There's lots of interesting points of difference between this and some of the other units or other things out there. I will go through some of those. First, let's have a look in the box. This is what comes with it. So normally you get a screen protector with it. This is what's in here. We have calibration cert, or verification really, isn't it? And some other bits and pieces in here. So there's cal cert. Packing list that shows everything comes with it, which includes 4 probes. And then you've got an English and Chinese thing on the back here, which is like a little quick start information thing, just to get you a bit informed about it. But there's one interesting point here. Measurement category. Measure up to Cat 1, which means not directly connected to domains. The reason for that is because these things are not isolated scopes. The scope is not isolated, so if you had the B and C's connected to a cable which is hooked up to a main circuit like a switch mode power supply or something like that, there was some kind of mains fault potentially, it would mean that everything that's metal on this thing would become live, potentially. That shouldn't damage the scope itself because it's floating, right? It doesn't actually have an earth connection. But if you're touching anything which is metal, such as, I don't know, this earth probe at the side here, you'll get a zap. So keep that in mind, that's why it's got that Cat 1 rating. One thing it does have is an earth terminal, so right there's a screw for actually doing earth yourself. So you can actually earth it out, which will then make it an equivalent of a bench scope. So that's something which is something to consider. If you're going to be doing any high voltage work, this isn't necessarily the safest way. If you take precautions and you're a little bit careful about what you do, you'll probably be fine. Just keep it in mind. If you can use a differential probe instead, keep it really safe. So other things in the box. Also you got a power supply here, power brick, which is for charging the unit or even just powering it. It's got an internal battery. And we have 2 packets of probes. Each packet has 2 probes in it. Alright, so it comes with 4 probes, which we'll need configuring for the device just to set the colour bands up, I think. And also these, I believe, are 300 megahertz probes, because this is a 300 megahertz scope. So it's called P300. Pretty good fit in that packet. Okay, there we go. There's the back. So yep, these are indeed 300 megahertz probes. Exactly what we expect them to be. So these are 10:1 probes. There is no switching on them. They are just 10:1 probes. Right, there's no switch. So the fixed value there is the derating curve for voltage. 600 volts rated to 1 megahertz, and then it drops, which is standard. This is really normal for probes. They all do this. So in a little probe pack here, you get some little tip covers. You get 2 of those, 2 of these little springs, and also got the alternative colours for the other channels. So these have already been pre-set up for channel 1, channel 2 with those colours. You might have to do the compensation. That's probably not a big deal. And then obviously the colour rings for channel 3 and 4, which are in the other bag as well. So all the probes are set up as channel 1 and 2, so obviously you have to do channel 3 and channel 4. So there's compensation adjustment just in there, and the actual probe is rated Cat 2, interestingly. So I'll be giving some notes here from Micsig, things I should be pointing out. You know, key features. Obviously 4 channels, 300 megahertz. It's got 2 gigasamples a second. That's based on single channel. If you go to 2 channels, it goes into 1 gigasample. 4 channels is 500 megasamples, as you would expect. Memory depth is 220 megapoints. For a single channel, obviously that gets divided down amongst channels, which is all quite normal. All scopes tend to do that. Maximum waveform capture rate is 300,000 waveforms a second. Bandwidths are 20 megahertz, and you also got high pass and low pass, which can go down to 30 hertz, which means you can set your own filter cutoff. So if you want to cut off a lot of high frequency noise, you're trying to say work on 1 megahertz or something like that, and you don't need anything above 5 megahertz, you could set your own filter. I haven't tried that yet, but apparently you can do it. Input impedance, it's 1 mega ohm and 50 ohms, so it actually does have a 50 ohm switch in it, I believe. Haven't tried that yet either. I've played with it a little bit, just to familiarise myself with it very slightly. I ports Wi-Fi, USB 3, USB 2 host, USB-C, it's got a grounding port, HDMI and a trigger output. So that's what's on the end here. So what I'm actually hoping is that this HDMI output will allow me to do like a direct feed into my computer from the output of this scope. And if I can do that, that'd be really good if I'm doing live streams, because I could plug this into my OBS system and stream what the scope can see. I can do something very similar to my Siglent scopes, but that's all through like a web interface and all that. This will be a different setup. I don't know, I have to try it out. Display, it's got a 10.1 inch TFT LCD, which is 1280 by 800 pixels, which is quite nice. And it's got 11 by 10 divisions on the graticle. It weighs 1.9 kilos of the battery, and it's got a 7.4 volt, 7.5 amp hour battery basically. So it's 4th generation of Micsig scope, and as I said before, it comes in 200MHz and 100MHz versions, as well as the 300, which is what I have here. Android based OS. Now this particular one, because this is the higher end model, there's a compromise between getting the high speed and the high performance compared to the other units. Now the compromise is that the battery life is much shorter. The other units I believe can do like up to 5 hours, like the lower bandwidth ones, so they don't actually require as much power. So this one is 300MHz, and it takes a bit more effort apparently. So, and it's also a decent sized screen and what have you. So this apparently can only last up to 2 hours. Now I've actually had this thing running for an hour and a half with 2 channels running. I didn't actually wait till it completely died. I still had a bit more power on it left, but about an hour and a half is what I got out of it. And apparently the 8-inch versions of the TO3004 has like 5 or 6 hours of battery life. So obviously the screen size and stuff like that, and the fact it's running basically a computer in the back end, there's a bit of work for it. On the top here, we've got Micsig probe interface. You can probably see it if I get the light on it right. You see the little connections there lighting up. Alright, so those are the universal probe interface. So if you've got the Micsig probe, you can connect onto that and automatically communicate with the actual scope, such as like active probes, things like that. So it's mentioned specifically the DP750-100, RCP500 and high frequency current probe CP503, CP1003. It's got 32GB of storage, which allows you to store video files like screen captures and waveforms and things like that for the scope. Remote control of a PC or smartphone, so you can actually get a smartphone app and hook it up. I haven't tried that yet. HDMI, as I said. Skippy functions. Segmented memory storage. This is one of the features that this particular scope has got. The lower models don't have segmented memory. This one has segmented memory. So if you need to do like long time period captures of intermittent waveforms or periodic waveforms, whatever, you can do that over a long period of time by using segmented memory, which is one of the benefits of this particular unit. It's got trigger and protocol decoders, some statistics. It's automatic setup as well. It's got a fast auto setup thing. Also, I wanted to mention these. You've got some new current probes, high frequency current probes, CP series. So you've got the CP1003. I might chuck links down in the description for these as well, so check those out. And also plan to release optical isolated probes. That'd be interesting. There's also another link here which I'll also put down in the description. And it's also got a fine control. So when you're using the scope, you can actually drag the waveforms up and down. It's all touchscreen, right? So you just drag them up and down. But it's also got a fine control here if you want to align something carefully. So just put a little note in the internet. So there you go. That's sort of things that Micsig wanted me to talk about. So let's get into it more. I've been waffling for long enough. So let's have a look at the outside. I mean, I've already showed you that end there and pointed out those details. It's got USB-C there. It's got a main power switch on here. So when it's transported, or if you put it in a bag or something like that, you can actually turn the power switch off, right? This is like a hard switch. So if this button gets pushed in, it ignores it. This is the actual power button. And if you turn it back on again, then you push that button, it'll turn it on. So I'm going to actually do that now. You can see how long it takes to boot up. On this side, you've got a handle, little hand strap, so if you want to carry it around or make sure you don't drop it. You know, you can stick your hand through there maybe like that and hold on to it, so that way you can actually use it one-handed like this, that kind of thing. So that's good. And also you've got the 4 channels along the top, and also you've got an auxiliary channel here, which is auxiliary output, I believe. So yes, it does have a fan. So when it boots up, it goes to the home screen first, and then it actually launches the oscilloscope. It's basically an app. I think it is an Android-based system. So I just want to show you the boot up time on this so you get to see it. Real time, there you go. So I've got 2 channels enabled right now, and I've done auto setup on this previously, which is why the waveforms are looking quite noisy, because the scaling is quite a way down there. It's currently set at 10 millivolts per division on each waveform. On the back, which I haven't shown you yet, there is the fan, there's the battery pack, and it also got these little legs that can come out like this. These are magnetic. They just hold themselves in quite nicely. And with those means you can then spin it around and lean it back like so. This was sent to me by Micsig via AppVision Australia, so it's an Australian distributor. They sent it to me here in New Zealand, so make sure you go check out the links to go to them or to other Micsig sources maybe. I'm sure Micsig will have a list somewhere or something like that and provide me links. So make sure you check out the links down below for anything relating to this. There's manuals and everything available. The manual for this thing is huge. So the manual for this thing, which is available online, is 355 pages. It tells you how to use everything, I think. It goes into incredible detail to tell you how to use things. So if you really need to figure out how to use something, not by just trying out, which is how I learn, but by reading, you can go and read that manual and it'll tell you how to use all these different functions. And it goes into great detail. It does explain things very, very well. It's an excellent manual. It's probably one of the best manuals I've seen in ages. It's really impressive. Just the amount of work they put into doing the manual gives you some idea. You know, that is really well done. So good on you, Micsig, for doing a great manual. Well done. So I'm just downloading an update on this thing and it's taking forever. It's only got 593 megabytes to download, right? It's not a big update. Look at the speed. This isn't my Wi-Fi network this time. Sometimes it is, but this time it isn't. That's incredibly slow. So I think it must be like Micsig's server or something like that, or it's just really slow. I don't know why it's that slow. It's taken ages to download this thing. So I haven't actually tried doing any waveforms on this thing myself yet. I've played with the UI. That's what I've done so far. I forgot the UI a little bit. So let's actually hook up channel 1 to channel 1. And we'll do the probe compensation because we need to do that. Kind of got set to auto ranging. Alright, not auto setup, I think. Let's select it, we can change how it actually works. Just trigger level, like that. That's triggering nicely now. You can see the probe compensation needs to work. So let's rejig things a bit, try and get the glare off the screen. So let's bring this channel down a bit. So if you want to change the waveform heights, you can do it up here and there. You can't really see it too well here. I might actually turn some lighting off a bit because my lighting is really bright here. Hopefully that's slightly better. So I do actually have the brightness turned up quite a bit on this thing already, which I think shortened the battery life. That's why I didn't get the 2 hours that I advertised, because I had the brightness turned right up, ready for filming. So when you tap on a channel, you get these icons pop up each side, above and below, which will change the actual size of the vertical resolution. Okay, so if I want to do channel 1, I can make it smaller here, like that, or I'll make it bigger with this one. And now you can see our probe compensation is quite a long way out, so let's fix that. So thanks a lot, Micsig, for sending this to me at no cost. I should actually mention that specifically. Micsig has not charged me for this, so I got it for free. Right, for the purpose of review. Let's try and get this in here. So there's a slight misalignment between the actual adjustment and the outer housing. So I'm in trouble getting the actual screwdriver head in there. There we go. There you go. So what we'll try and do is get the undershoot and overshoot balanced. Right, so it should be, don't undershoot, we don't overshoot. You've got to get it just right in order to prevent waveform distortion. So I think we're pretty close there. Okay, that's looking pretty good. Okay, happy with that. So let's have a close look at the UI. This is one of the things I'm known for doing, is playing with oscilloscopes on video and just showing the user interface. And sometimes I get a lot of criticism for that, but that's just the way I like to do things, and just show you how you would find the scope. So I'm going to leave the sampling waveform on here. As you'll see over here, I've plugged it into power just so it's not going to run flat. I mean, I'm going to potentially be recording this thing for hours and hours, so let's just run it off this. As you can see, it looks very different straight away because it is touchscreen. If you want to turn channels on and off, you've got the tabs down the side here for the channels. Right, so if I want to play this channel over here, for example, I can bring it over like this. You can turn the channel on and off, you can invert it, you can change the coupling and that sort of stuff, voltage or current. 10 times is because it's 10 times pro by default. You can change that, obviously. I mean, what options are there? All the default ones, so that's fine. Full bandwidth, high pass, low pass, 20 meg. So if you want to do, a low pass filter, 30 kilohertz, you can do that. Or high pass 30 kilohertz, and you can put whatever you want in here. So you can just drag this around and get the actual filter you want. That's the fine tune. This is the coarse tuning. So that's nice. I'm just going to leave it on full bandwidth for now. 1 mega ohm, 50 ohms. See if I can hear it click. Yes, it clicks. So there must be a load resistor in there. And we can actually probably demonstrate that on the other channel as well, actually. Voltage reference, vertical scale, 0 and centering. And you can also do labels, so if you want to call it a certain thing. Like there's some preset ones here too. And if you want to use your own one, you can do user definition. So if you're doing like a SPI or I2C connection, you want to make it easy to track and visualize, you can use the predefined ones here. Other ones, RxTX or for UART or what have you. Okay, so lots of options in there, that's quite nice. So if you want to turn it off because you don't want to use it, we can do that, and that's off. And it will just show you the active channel any other channels here. Now level here, this is for the trigger point. Right, so you move it up and down. Or you can also drag it over and you've got these different kinds of triggers and which channel you're triggering from and that sort of stuff too. It's all in there. Also, this scrolls up and down. You've also got math and reference and decoding options on this side as well. So you want to do math functions, you can do those. Again, you can drag that out and you can decide what you want to do, as well as your own advanced ones. It's got FFT as well. Haven't played with that yet, but it has it. Reference waveforms, again, same deal. You can do references and you can store them and record them in there. Decoding options, you can turn it on and off, bring it out. You can choose which ones you want to do. These are the ones that are currently available. There are optional ones you can get extra. These are the default ones. I'm not sure which options you get by default. I may have this one fully optioned. I'm not sure. Also, you can choose which channels, the bits. In this case, like as you are, if you're doing I2C or I2C, however you want to pronounce it, you can choose SDA and SCL, which channel you're currently on for those. So you can choose which ones. Just pick a channel and it will use those for those signal lines. And it also specifies I2C decoding down here. Or you can turn it off because you don't want to use it. Done. That's those, and so you've got two decodings. You can use both at once. If you want, you can do two different decodings at the same time. Because there are 4 channels, you could actually potentially, you could have UART on one, SPI or something on the others. That's the side menu. At the bottom we've got another menu here. Screen capture, zoom, all measure, so you want to do measurements. There they all are. You can also set your own ones up and that sort of stuff. If you want to get rid of it, drag it down again. Okay, 50% mark. So you can choose time-based, levels, cursors, positions or whatever. You can set those wherever you want. Channels, you can choose which ones you want to use. Math channel is currently on, so I'm actually going to turn it off. Without the math channel running. If you have multiple channels, you actually choose which one you're trying to control. So if I had, say, channel 2 turn back on again, then you can choose which channel you're actually adjusting. Or, you know, the all measure is showing either one, which is a nice feature. You can switch really quickly between the two. Also have cursors, so if you want to do vertical cursors, horizontal cursors, that's all right down there as well. Quick to access. This is also movable. If you want to move that around the screen, you can do that. I don't really see the point. I'd rather just keep it down there, close to the button. And we also got saving and fining, so this is that fine adjustment here. So I've got channel 1 there. If you want to do the fine adjustment of moving up and down very slightly, you can do that. Or you can zero it as well, which does that too. Top screen. Drag that one down. We've got even more stuff. There's loads of things in here. So measurement functions, you can choose which measurements you want to do. Common measurements, you can turn them on and off. Like I'm showing IMS peak to peak and frequency. I just come over here and turn it all measure off again. Those are the ones I'm using just down here. Okay, that's what I chose to use. Those are the ones I often use, so they're the ones I like to use. But you can choose any of these ones. You've got statistics as well. You can turn those on if you want statistics, which gives you this information in this case. Counter, so this is a frequency counter. You can choose which channel you have it on, or you can turn it off if you don't want to use it. Save functions, you can save locally or to a USB disk, like a flash drive, you know. WAV file, CSV, bin, and you've also got reference waveforms you can save them to as well if you want to do that. That's for waveform settings. Actual settings, so you can set up your own user information. So if you have a particular way you want to use it, you might have different ways you use it. It might be like a different kind of testing you do, different scenarios, and you have different configurations. You can actually save those and restore them. If you're doing like RF work and you want to measure RF stuff and you've got a certain way you set it up for that, you can save that method. You can name it whatever you want as well, and then you can just restore it and do a recovery, and that loads that setup. You're doing digital decoding, you have a setup for that, and you can save and restore that one. And so there's loads of options in there for that one. Picture, so you want to take screenshots. You can also invert the colour. So if you're doing printing, if you want to print this out afterwards, you don't want printing black. Right? If you can invert it, it inverts the colours around, so it's easier to see it if you're going to print it out, and obviously timestamps on there. Samples, so we've got standard modes, so normal, average, envelope and peak. Depths, adjustable, set an auto right now, which means it changes up and down depending on how many channels you're active. Segmented storage, so how many segments you want to store. If you don't want to fill the whole memory up, you just want to grab, say, 100 samples, for example, you can do that, and it will do your list as well and that sort of stuff. Not something I've actually tended to use myself, but I know it's something which some people do use, so it's there, and it's really nice. This particular scope's got it. Display options, common settings, let's start over here first. So you can choose the horizontal reference, which means center or trigger position. So when you move it around, if you zoom in and out, it'll either move it around the trigger point or the centre of the screen. So if you set the centre and you've got the trigger over here, the trigger will go off screen. Now I tend to go on trigger position. That way, if you got it zoomed in, you got the trigger over here because you're trying to see like a digital waveform or something like that. You know, trying to capture an I2C packet or something. As you zoom in and out, the packet will just grow across the screen like this, and the trigger point will stay in the same place. So I tend to do that way around. Vertical and time-based or XY mode. Waveform, dots and vectors. Do dots. In this case, it doesn't change it much. I've got the brightness turned down, sort of average. It's bright enough on camera, so I didn't worry about that. Graticore I'll turn up a little bit so you can hopefully see it on camera. Maybe I'll go a bit higher with that. Yeah, you can see it slightly better now probably. Full Graticore, where you've got grids, which is just dots. Different types you can use. Right, so clear on that one. Persistence is currently set to auto. I don't know if I need to change that. I may or may not. But you've got normal modes and infinite persistence, and you've got adjustments and stuff too for that. Triggering. Start in common mode again. Hold off time. Auto normal modes. The trigger. Right. You can set this to almost anything you want, I suppose. But again, it's got the same scales, coarse and fine over here. Edge triggers, again you choose what channels, and vice full dual edge, so that checks for both. Coupling methods, high frequency rejection, low frequency rejection, noise rejection. Pulse width options as well, so you can choose pulse width to trigger on. Logic states, so you can choose what logic states across different channels, using all 4 channels. And so you can choose if only trigger on a certain condition if all 4 channels are a certain way, for example. That's a nice one. Nth edge, so how many pulses there are for it will trigger, for example, or how many rising edges it detects or falling edges or whatever. Front pulses, again, all fully configurable. Slopes, timeouts, video. If you're trying to do video work, you may need to use this particular mode. Not something I've ever used. S1 UART, so you can do start bets and stuff like that as well. And this actually drags across, and you've got S2 as well, which is I2C. Now these are obviously because of those what I've got set up on those particular modes. So I've got S1 as UART, S2 as I2C. So this is in how you can configure the triggering for that. You know, if you're trying to find no ACK or start or stop, whatever, I've got these set to start. Auto mode, so up here I've got to set auto range, which is turnable here. I'll do that instead, that's auto set, which is automatic setup function instead. So if it finds the waveform and does its best job of trying to set it up to that pseudo waveform, so if I do that now, there you go, auto set, done. Pretty quick. But I wanted to have auto range set, so it just automatically scales itself and only on the vertical resolution, only on the vertical axis. I didn't want to change the horizontal. And user setup. And you've got factory reset, self adjustment, stuff like that. So I'm not going to mess with that at all yet. So that's that stuff. Run, stop. There's the frequency counter. Those are just displays, don't do anything. That doesn't do anything. There's nothing on the left hand side, there's nothing over here to do. But like I said, if you want to grab the waveform, you can drag the waveform down. The trigger will move with it. I think that's covered most of the user interface. Go to home. So this is the main home screen. Like, this is the Android operating system basically. Now I've actually janked things around a little bit in here. They weren't laid out this way when I first got it. I've changed it around a little bit. So you've got a user guide built in here. So you've got basically instructions how to use it. You've got a calculator. That'll probably be handy for something. This arrangement down here, I'm not an Android user, so this is a little bit foreign to me, but I figured out this is the home button that takes you back. WPS Office, I've installed that. It's one of the options. I've installed it in there. Gallery, so you've got any screenshots and photos and stuff in there. Yeah, just allow it, whatever. Web browser, you can actually browse the internet on this thing. This is on my Wi-Fi, and so it's going to Micsig's website right now. Viewing their own website on here. Isn't that nice? So this is this one here. Here it is. Right here. Anyway, so that's that. Close it off again. Files, so if you've got anything else stored on here, you can use those because it is basically an Android device. App market is very limited. It's only what allowed for by the system itself from Micsig. So also got Oscilloscope, Office and File Explorer. Those are what's installed. I've installed these two here. They weren't installed by default. Obviously Oscilloscope is. Settings, so network stuff, display options, there we go. Brightness level, I've got to turn up quite high so you can hopefully see it on screen. Standby, I've got a 60-minute standby, but yeah, anyway, that's what I've got right now. System info, that's what I've got set up for that. It's a bit limited in what it's actually got, but then you're not really meant to be using this as a phone, are you? So, and this is the information about the actual scope. Android version 11. System upgrade. There is no new version. I've already done an update on this. It did actually have an update waiting for it. I've installed that already. So that's done. You've got this electronic tool thing here, which is like a little internal calculator thing, I suppose, for doing different functions. Right, little handy thing. If you want to refer to bits of calculation, you know, looking at parallel resistance and stuff like that, that's always a handy one. 312 voltage regulators, this is also a handy one. Yeah, that's just what's built into that. I don't think there's anything else there. Could be handy for you. Obviously back here is the actual oscilloscope itself, which takes you back in here. We should actually hook this up to something other than this test waveform and do some decoding. I actually have something I can use for this. I'll demonstrate decoding. This protocol simulator board from 0 Plus. Now, this is one of the things they sent me a year or so ago to do a review on a logic analyzer they sell. This is one of the things I actually included is this simulator board, which means I can hook up this scope to this simulator board and we can see what an I2C signal is decoded like, or SPI or whatever. Right, it does. This particular board does lots of different protocols. I need to set up other probes, so I've got the channel 2 probe set up here. I need to do compensation on this one. Also, it's not triggering on this because it's not set to trigger on that right now. So let's bring this over. Trigger on channel 2. And there we go, trigger on channel 2. Let's just adjust the level up a little bit. Yeah, that'll do. Easy as that. This, as I said at the beginning, is not isolated, right? So I've currently got this thing in charging here, that's charging. So the negative of that jack there on the DC input is actually connected to all of the negatives on these jacks up here, right? So all the B and C's, these are all connected together on the outer jack, right? So these are all earthed when you got it plugged in. And the same for the USB as well. So the USB ports on the side are also connected to all these. So if you have this connected to your computer, be careful what you're doing, because if you're connected to the computer or maybe even HDMI, you are linking that device to the device you're testing. Just watch out for that because it's not isolated. I've actually got two boards of both two different protocols. So this one I'm going to use for this because it's got I2C and SPI on it and UART. So it makes it nice and easy to use. Those are the three I probably want to play with. Board set up just here, probes are on it, and I'm getting some data out. I'll just get a bit closer and see what I'm talking about. And a single capture here, so do sequence. This is actually a changeable state button, I suppose, depending which mode you're in. I think this is something Micsig need to change actually, because this is a bit confusing. Because when you're in single state, it should really say single, but it says sequence, which I think is like segmented memory. So this tells you the current run state. Okay, if you do that, it goes run, then stop. It grabs a sample of the whole lot. So you can actually zoom in on this, and you can see the decoding of the packets down here in the bottom here. So you can actually move this up and down. Originally it's overlapping, so I've moved that around a little bit. Okay, so it is actually decoding. Now it's doing decoding hex. I couldn't see a way of actually changing that to decode as ASCII, but anyway, it's just the data it's doing, I suppose. And there's the packet there. So that is doing something. What data I'm supposed to get out of this board, I've actually no idea. So let's look at segmented memory. So this is doing a single packet. If I just do a normal run, it's just going to be whizzing past like this, and you can't really make much sense of this unless you do a stop and then zoom in a bit. Alright? So you can do it that way, or you could do it through here and do a zoom with that instead. Okay, it's another way of doing it. So you also see the bit you're actually looking at here. Right, that's actually quite a nice interface. Come here, turn the zoom back off. To do segmented memory, so over here, settings, sample, segmented storage, turn that on. Now this seek button is now different. So if I tap it now, that's going to do segmented memory of 100 triggers. Anyway, fit. Here we go. So it shows them all on screen. Or you can play them back. that's segmented memory stuff. So I've just set to 100 samples. You can do a lot more than that. You can do, you know, 100,000 or something like that, whatever it was, because I've got 2 channels active. Do maximum. Yeah, so I've got 10,000 samples we can take there with that one, in that particular setup. Then we can stop it there, and same thing. Right, but that's how you use the segmented memory part. I wanted to show you that. So let's look at something else. Well, after a bit of messing around, I think I've figured out the setup for this UART on this thing. It's on this simulation board I've got sitting here. So I've got the setup here as idle low, 8-bit, no parity, 9600 board, and we're getting stable readouts on here now. It's jumping around as it should be. So if I do a single capture, so it does seem to be actually correct at that particular sample. Maybe I'm wrong, but it seems like it's stable there and it's looking like it's what it's supposed to be now. A bit messing around trying to figure out what this board is actually supposed to be outputting. It is obviously decoding in binary just fine. Obviously you can do, you know, hex instead. You want to do hex values instead, or ASCII, which is just gibberish on this thing. Obviously it's not meant to be doing ASCII, it's supposed to be doing binary, it looks like it. So, and if you're interested, I was actually powering that off the oscilloscope itself from this connection. I've now got a signal generator set up on here. It's my RF signal generator. It's got to 1 GHz. I'm inputting 100 millivolts, and that's what I'm getting here, RMS, and at 1 MHz, and we can see that just fine, no problems at all there. So let's just change frequencies, go down to say, I don't know, 100 kHz or something like that, and now we're getting 102 millivolts there. So it's not perfect fat. I'm running off a BNC cable here. I've got it set to 1 times on the probe here, and 50 ohms input there as well. I've changed 50 ohms instead of 1 megohm. So let's do, say, 5 MHz, and you can see that just fine. Frequency accuracy is not bad. 1 MHz is really good. 5 MHz is slightly out there, but it's not too bad. Bring this down enough. You're getting a reasonable display here. Right, so 5 MHz, still about 96 there. Okay, let's do 10 MHz. 10 MHz there, it's looking really good. Accuracy on that counter there. Waveform there is good as well. What I'm going to do whilst I'm here, I'll turn modulation on, and I'm going to set it to 90%. Now you're going to see, get this aliasing here, because we've got a 10 MHz there with a 1 kHz AM modulated carrier. Let's bring it down. There's the AM there. See that difference? And triggering is going to be an issue. Let's see if I can get this thing to trigger. Put it down here, trigger, common, hold off time. And let's play with this hold off time and see if we can get this to actually get a stable trigger. If I do a stop on this, let's do it this way, I'll show you. It's 500 microseconds per division. So we are over that. We want basically 1.5 divisions. So I think we want about 700 or 800 microseconds for that hold off position. So we're currently at 15, so I think we need to be about here somewhere. Alright, bring it up. Actually, I'll show you whilst it's running. Run. Hold off. There you go, 600's got it. There we go. If you want to do fine tuning, you can do it with this one instead. When I go too far, it will start glitching again. There you go. Glitching again because it's now doing hold off across 2 waveforms, not with 1. So yeah, that's working nicely. I do like the fact you can just tap somewhere. If you know roughly where you need to be, you can tap it, you get it close, and then you can do the fine tuning to get it there. There you go. That works fine. No worries about that. So I've turned the modulation back off again, so we can come back up here, back to where we were. Let's increase frequencies. Go 50 MHz. Still no worries. Level's still good. 100. Still good accuracy on the frequency counter there. Level's still good. 150. Level's still good. Good accuracy still. 200. Still good. Level's actually increased slightly. 250. 250 MHz here. 250 up there. Level's still good. Let's do 300. I'll look at the DOS display in a minute as well. So 300 MHz. And that started dropping. So what we should be seeing here is 70.7 as the bandwidth limit. So 330, 350. There we go. 350 is pretty close to it. Let's make it a bit bigger. Yeah. So this is exceeding spec. We're getting 350 MHz here. So that's pretty good. So let's go 400. Still see it. Still count it. That's good. 450. That's doing alright. That's 450. Our trigger level's a bit rubbish. We need to bring our trigger down. You know, get trigger in properly again. So 450, and the counter can't measure 450. Let's try increasing the waveform size. There we go. Now it's got it, 450. So although it's way above its spec, it still can count it and it's still usable. We're getting some bouncing here. So let's actually look at the dots display. Put it on dots display, and there's dots on display there, which I can see if I do a stop. I don't know whether I sharpen camera, but there's dots there, 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 there. Yeah, so at that frequency it's pushing it a little bit. Let's just reduce it, go back down to 350 again. If I shrink it down, maybe you can see them a bit better, and reduce the scaling. There we go, there's the dots there, you can probably just see them. Maybe just see it there. Just see the sine wave with those dots. So at 350 there's actually enough sampling there to give you a reasonable representation. At 350, 300 MHz, slightly better. So back to 450, level drops quite a bit, but you can see them there still. Still see them there. 500, you can still see them there. Cool. 550, you can still see it. If I do a stop on that, you can see we're getting to the point now where that's definitely going to be not much good for waveform values. I'll increase the scale a little bit there, do a single capture, and it's not enough there really. So 550 is not really there. Frequency counter's not really keeping up there either. 10 millivolts division, yeah, it's not really there. Although it can kind of do 500. 450 I'd say is probably the top of where you want to even consider trying to use it. So let's go back to vectors again so we can see it, so you can see how jagged this is now. Right, so 450 is really not looking good, but at least it actually shows you that it's not looking good. Right, 400, 350 and 300. Interesting. It looks like it's actually gone between two states here, because it's not actually doing sine and X on X now. I don't see a sine X on X option on here. So I definitely did something with this then, because now I'm back at the 450 again, I'm getting nice smooth sine waves. So what did I do to cause that to give the jaggies? Was it in dots mode I could increase the resolution? So what caused that to happen, I wonder? Back to vectors, it's jagged again. But before you saw that was smooth. Down, back up. Now it's not jagged. Isn't that interesting? I think I found a bug. Excellent, I like finding bugs. So let's replicate that. 450 MHz, that's above its recommended ratings. Anyway, actually, let's get down to 300 where it's supposed to be, right?
A few moments later.
Right, so we do a time base. Down and up. It's something to do with that. Dots mode. Down, up. Vectors. Noisy. There we go. And we go down and back up again. Now it's fixed. Got it. Minor little bug there. Obviously it turns off the sine X on X for some reason in between those states. So you go in dots mode, bring it down, bring it back up without overscaling. Then it's jagged. You bring it down, bring it back up again. It's fine. Minor bug. Okay. I found something wrong with it. Always like to find something. But it's otherwise good. That's doing 300 MHz, absolutely fine. Well within spec. We've already determined that. So as far as bandwidth goes, this is excellent. Let's try that high frequency again. 550 MHz. So 10 millivolts division is as small as it can go. And you can see that's not really usable there. Obviously there's not enough sampling here, but it's jiggling around everywhere. I've seen the same thing on budget scopes below their rated frequencies. Give you some idea. This is not a budget scope, this is a good scope. So 500 MHz, not quite. Obviously it's below Nyquist, it's not good enough for Nyquist. And there we're looking much better. So 450 MHz is definitely usable. That's actually really good. And as I said, 350 exceeding the spec. It's exceeding by at least 50 MHz, which is brilliant. Now you're probably thinking, now I'm going to do a teardown on this thing. I am not going to do a teardown on this. This is something which I do not want to pull apart. I don't want to risk doing anything which would potentially damage it. It's a really nice scope. It's the first Micsig scope I've owned. A bit of this was me getting used to the user interface, figuring out where things are. But it's basically fairly straightforward. Once you figure out where the menus are, you can go to things pretty quickly. It's not really that hard. I'm really happy with this. It didn't take much for me to figure out the user interface. Probably I spent maybe half an hour poking around, just figuring out where some of these things were, how to use it, where the drag things are, what happens when you tap things, that sort of stuff, right? I really like it. The time-based here, you can also tap in, just go straight to one, instead of toggling through. Go to 1 kiloseconds per division. All these little shortcuts in there which you can use as well, which I haven't really shown you that much. The build quality of this seems really good. The quality in general seems really good. Micsig have definitely come a long way in the years since they've started, and they're becoming recognised now as a decent brand, I think. You know, they're getting up there and they're doing quite well. Certainly comparable to other scopes. I think this unit retails for about $2,000 New Zealand. I think it's about 1,300 US. I could be wrong. Check out the website links down below to find out. I could be misquoting. But for 4-channel scope, which can do 350MHz and portable, it's awesome. So thanks a lot, Micsig, for sending this to me at no cost. That's brilliant. I'm really happy with this. It's a beautiful piece of gear. I'm actually really impressed by it. And I've reviewed many scopes. User interface, portability, it's got great potential. So this is the 4th generation, so they're really refining their act now and they're getting quite good at what they're doing. You know, the only thing I wish this had was more battery life. If you wanted more battery life and you weren't so worried about the higher bandwidth, then you could get a lower model with a lower bandwidth ratings and get more battery life out of them instead. And in my case, like you saw, I've plugged into power here and I've been using it on the bench with power. If you push the button on top it, I should show that. You can do, you know, sleep modes and locking it and stuff like that as well. And shutting it down with this. I'm going to shut it down now. Shut it down. Right, I'll turn it off. Turns off that quickly. And it doesn't take that long to boot up either, as you saw. So if you weren't going to be using it for, you know, 10 minutes, there's no reason why you couldn't just power it down or put it to sleep or something and save some battery life when you're using it. Battery life is a consideration. Now, interestingly, is in the manual for this, it does actually stipulate the battery life as being 4 to 5 hours. And obviously, I'm not getting that. Micsig himself said to me, yeah, I won't get that, I'll get maybe 2 hours. That's what I've observed. I think they need to stipulate in the actual manual for this saying the battery life per model. So expected battery life for the 300MHz, expected battery life for the 200 and for the 100. I think they should actually stipulate that on the user manual or at least the data sheets or something like that. It doesn't say 4 to 5 hours, and on this particular version, 300MHz, you don't get that. I think they need to spell that out more clearly somewhere else, because it's not actually mentioned really in the manuals or data sheets about that particular limitation about the battery life on the higher bandwidth model. I think otherwise it's a really good unit. I mean, it's just a little detail, and I found one little bug, and it's actually really good for me to only find one bug whilst using something. That's the first bug I found, with that little waveform glitching there with the sign X on X not showing up. Minor thing, and that's the only bug I found. And normally when I'm working on the scope and doing a review, I'll find a few bugs or things I don't like. It's only been the one thing. It's been really good. Check out my other videos down below for other reviews. Subscribe over here if you're not subscribed yet. Don't forget to click the bell icon. And over here, there's a Patreon support link if you want to support me on Patreon. Help me to buy things to repair and that sort of stuff. So click like and subscribe. Catch you later.